the idea was they used what's known as hydromechanical. They use flowing water as it descends to spin a water wheel, which then would spin through gearing, would move machinery to make for either forges, trip hammers, bellows. Initially, what the company used in the 1820s was just a little stone diversion wall that would force the water into a single hydromechanical unit. By the late 1820s, by the late 1830s, I mean, they built their first dam across the river, a stone dam, which was more effective and could shunt more water, which meant more power to power more gears and more equipment. What they soon developed is a really remarkable series of, from the one intake at the dam, a series of canals that would power multiple machinery in different buildings, and then they would all sort of work their way back down to go back into the river. So the current dam that's there now replaced the original one. The current dam was built in 1867, and good heavens, what's that, 160 some years? That is really remarkable that it has stayed that long. So at the same time as they were building their new dam, their current dam, just a couple of years before, the Collins Company joined with a couple of other companies to develop the Otis Reservoir up in Massachusetts, which was one way that they could try to assure themselves of a steady flow of water. Sometimes the Farmington River can be a bit flashy, it can rise and fall fairly easily. What a manufacturing company needs is steady water. They need steady power. And since they relied only on water power at the time, they needed that steady flow. The Otis Reservoir was their first attempt to assure themselves of a steady flow. The company grew with more output, more manufacturing capacity. They needed more and greater amounts of power, which meant more water power at first. By the early 20th century, they started to implement some very small-scale hydroelectric generating units, but more they started relying on steam engines, coal-fired steam power to supplement the water power they have in case the water went low. If there were a number of dry years in the early 20th century, even with the Otis Reservoir, their water supplies ran low, they would have to supplement the power they needed to keep producing axes with steam. So as early as, well, before 1907, the company began investigating the possibility of a second dam downstream of the plant to help assure themselves of a better power supply. And the idea was, by that time, in the early 20th century, hydroelectric power was becoming more the thing. It was becoming more available, the technology was developing. The idea was they would develop a hydroelectric facility downstream to supplement the work at the manufacturing plant upstream. That's where the lower dam comes into play. So they were beginning some initial plans, 1905, 1906. They agreed to go ahead with it by roughly 1910. They began their engineering work, their design work. They acquired a property by about 1910 along the river. They did the formal surveys, 1911, and then construction on the lower dam with its hydroelectric generating facilities began in August of 2012. Largely complete by late 1913. I think maybe they finished the powerhouse installation maybe in early 2014. I'm not sure yet. This is still in progress. So that's how we got to having a lower dam. And it had, eventually, we can show the relationship here. Eventually. Wow, that is slow, isn't it? It's thinking. So the lower dam had, here we go. You can see the relationship. The red line shows the entire Collinsville National Register Historic District. With, you obviously know where the dam, of course, right there in the center, the upper dam, and then the manufacturing capacity in there. The lower dam is roughly a mile downstream. And the idea was that there were several purposes to have the lower dam. One was they could build it for hydroelectric power. And the idea they would run they had lines that then ran from the generating station back up to the plant. And it would help them to reduce the need for coal-fired steam plants. Coal is expensive, and you have the one-time cost of the plant, of the hydroelectric plant. You can supplement less expensively. In times of high water, the company could make use of the same water twice. So they could double dip, they could generate power. They had a hydroelectric plant at the upper dam by 1935, I think. So they could double dip. They could use the same water generating power twice. In times of lower water, they would let the water flow through the upper dam, pond at the lower dam where they could generate hydroelectricity. So it had sort of a three-pronged purpose. It was really really quite an ingenious design, especially that early in the history of hydroelectric power in America. This is really very early. So just to run through the facility itself, it really the lower, we talk about the lower dam, but it really is a complete system there at the lower dam. The dam is one part of it. The dam across the river, there's a sluiceway at the west side, that lower side, the gatehouse at the upper side, the power canal that runs along the east bank, feeding water down to the powerhouse. The reason you run the water down this power canal, it's not a very steep river, so by moving the powerhouse about 650 feet, I think, downstream, they gained another couple of feet of elevation gain, so another couple of feet of head. The amount of electricity you can generate, very simple ways, which is all I can talk about it. A combination of volume of water and the head, or the difference between the pond elevation and your tailways elevation. So the greater distance you can have the water fall, the more power it can generate. So since it's a pretty flat river, move it downstream. I think it was a two or 3 feet effective head difference by moving it downstream, which makes a significant difference. So just to see these parts, we'll talk about the individual parts in just a moment, but here we go. This is a little schematic that maybe shows it a little bit clearer. The dam, here the water pounds up behind the dam. The river is flowing this way. There are sluice gates here at one end, and there are 3 4-foot square gates. If they need to draw the impoundment down, it's a way to flush some water out of the impoundment. The gatehouse here is what can allow or disallow water into the power canal. Leads down to the powerhouse with another little option for another little sluice, uncontrolled sluice, that if the water gets too high in the power canal, the water can shunt out without damaging the powerhouse and the electrical equipment in it. And then this elevation view, this is, as we're looking downstream, I was astounded when I saw this. This dotted line here was the original ground level. So you can see how much they excavated on that east side to create the ability to flow into the power canal. It's, the ground actually passed through what is now the gatehouse. That was an awful lot of excavation. So as we start moving into the components, you can see the the section view of the dam there, they call it a sort of an OG shape, curved so that it allows for the water to flow over it and move straight downstream without undercutting the bank. Undercutting underneath the dam. So eventually, we'll start seeing, we'll have another little detail of that. The main part that we talk about is the dam, and what we see with the water flowing over it, it's identified as the spillway. It's designed to let water flow over. What they could do, and they often did, was to put what they call flashboards, which is a series of just plywood boards held in place by iron spikes that could raise the effective head another 3 feet. So again, to create a little bit more head, a little bit more generation. It's a 400-foot long dam in total. That spillway is 300 feet of that. About 40 feet of it is the sluice gates on the west side. Again, it had 3 4-foot square outlets. Each of them controlled. The gates can be raised and lowered manually by gates. You can see the remaining gate control operators there at the top, which I just did that back in April. So they're still very much there. And then the schematic shows it's a similar view. So that's the ones that, again, that allows water they can lower the impoundment if they need to. If there's too much water, if there's a flood, if they need to do some work on the dam, they can help to move the water along. On the other side of the dam is the concrete abutment, 60 feet from the end of the spillway to the bank. And on top of that abutment is the gatehouse, the brick gatehouse on top. Within the abutment, there are 6 gated openings. Each one is 6 feet by 8 feet. And each gate is controlled individually and manually by, again, a series of gears that will move, that can lift and raise and lower each gate. So that gate lifting equipment is actually still in the gatehouse now. But this section view, you can see there are the 6 gated openings below the brick powerhouse. And the purpose of the gatehouse is to control water into the canal. You can either allow lots of water in, or shut it off completely. Currently, the gates, of course, are closed and locked shut, which has allowed the power canal to go completely dry. But that's another feature of this. An important feature of the overall hydro facility is the canal. It's formed by a concrete wall going from the powerhouse down to what was the original bank. They're then excavated into the original bank to form the canal or the raceway with masonry stone blocks on the original cut into the original shoreline and concrete on the river side. The power canal, of course, led directly to the powerhouse. Water ended up here at the upstream side of the powerhouse with this spillway off to the side that, again, would allow water to shunt off if the water in the power canal got too high in a flood situation. Here is the spillway from the downstream side. So the powerhouse is, again, it's a concrete substructure with a brick building on top of it. The water flows into one of 2 intakes. There are 2 openings here in the foundation of the powerhouse. The powerhouse had 2 generating units. Each generating unit, there was a water wheel at the floor, below the floor level. The water would come in from the power canal here, come into this chamber. As it went through this draft tube and up to the river, it spun this wheel right here at a pretty good clip, that was then connected by a shaft connected directly up to the powerhouse floor where there was a generating unit, coils of copper coils charge, the rotor spins within a stator, generates electricity that was then sent to a step down facility nearby and then sent up to the factory. So what remains now in the powerhouse are the four walls, the window opening, and these were the housing for the generating units, and they are open down to this level. You look down and it's a little bit of a scary view down there, I gotta say. I was very careful when I looked into those. So again, just some of the remaining equipment at the powerhouse. There are the intake gate mechanisms, again, were manually controlled, as well as the little lift gate will be showing up on your screen any moment now. There was also, in addition to the uncontrolled part of the spillway, there was a smaller opening at the base of that little spillway that could let even more water out. And the machinery on the right there is that hoist with that smaller gate base. Again, manually controlled to lift and to follow. Just to take the lineage of this lower dam complex. It's really not just the dam, the complex itself. When the Collins Company closed in they announced they would be shutting down in 1966 for a number of reasons. One of the really big questions in the newspapers at the time was what will happen to the water rights? What's going to happen to the dams? Who will own the water? Who has the right to use the water? When the Collins Company was founded in 1826, their first move was to buy an existing sawmill and grist mill which owned the water rights. They had the right to use the water of the Farmington River in that section for power. So the question in 1966, 140 years later, well, what happens to those rights? And there was a lot of discussion in the newspaper at the time. Different nonprofits, different agencies were trying to figure out what would be the best. By early 1967, the Hartford Electric Company, which had been buying and selling power to Collins Company since the lower dam was built, really. Helco, Hartford Electric Company, they closed on the deal to purchase the water rights, including both dams and both hydroelectric facilities, in early 1967. They, as a part of that, agreeing to that deal, they realized that the lower dam, well, neither dam, but especially the lower dam, was unfocused on. They didn't feel that it was feasible to repower it. They thought it would need too much of their time too much time and energy and money to repower. So they conveyed the water rights and all the equipment in the dam, the powerhouse, the raceway, the gatehouse, to the state of Connecticut. And that was accomplished by sometime in the spring of 1967. Again, it's a work in progress, I don't have dates yet. Helco reserved some land for their own. They reserved a transmission line route. I think they kept about 34 acres of land near the lower, but they conveyed everything else, and they at that time removed the generating equipment, the electrical generating equipment and the control equipment. They didn't, as far as we can tell, they didn't remove the water wheels, the runners. We think they may still be in the wheel pits. I'm not going down the road, that's for sure. So that's how we. So So that's sort of the lineage, the genealogy is how we're now involved in this. There were multiple attempts beginning in the late 1970s.